Now, let us represent firstly a situation of non-equilibrium. Put attention. This is the common budget line of consumer 1 and consumer 2. Suppose that, according to his preferences, subject 1 chooses this bundle. That has denoted by D1, sorry, of P, the optimal bundle of consumer 1. Since for consumer 2, this is the budget constraint, and his indifference curves are rotated by 108 degrees, the optimum point, say, is this. D2 of P. Clearly, this situation is not an equilibrium situation. Why? Well, it is sufficient to compute exactly the coordinates of these two optimal points. This is the coordinates of the optimal point of subject 1, and these are, the coordinates of the optimal points of subject 2. The demand of good 1 by subject 1 is given by this segment, by the length of this segment, while the demand of good 1 by our second household is given by the length of this segment. Do you remember? The coordinates of subject 2 are rotated by 108 degrees. So, if you sum this segment and this segment, the total demand of good 1, that terms D 1 of P plus D 2 of P, you observe that this sum is superior to the length of a basis of an edgeworth box. But the length of a basis is nothing but the total initial endowment of good 1. So you have this inequality. Is it clear? The total demand of our two households, according to this price system of codes, is greater than the initial endowment. And therefore, on the market of good 1, there is a positive excess of demand. Demand exceeds supply. For good 2 is the contrary, because the demand of good 2 by subject 1 is given by this segment, while the demand by good 2 by subject 2 is given by this segment. And if you sum this segment and this segment, you obtain a length which is inferior to the length of the height of the edgeworth box. In other terms, for good 2, the converse inequality holds. And therefore, for good 2, there is an excess of supply, or if you wish, a negative excess of demand. Neither the first nor the second market are in equilibrium. This is a well-known result. If the market is not in equilibrium, also another market must be not in equilibrium. However, let us simply limit ourselves to note this situation. Both markets are in disequilibrium. And the reason, from a graphical point of view, is simply that these two optimal points do not coincide. In effect, suppose that by suitably changing the price system, we obtain this second situation. This is omega. Price system is changed according to Van, since there is a positive excess of demand of good one, the price of good one is increased. And suppose that according to this alternative price system, the optimal points graphically coincide. So this same point represents both d1 of P and d2 of P. Well, it is clear that if this is the situation, we are in equilibrium. Because repeat the procedure of before. These are the coordinates of the optimal points d1, and these are the coordinates of the optimal points d2. So consider, for example, good one. The demand is the sum of the demand of the first subject and the second subject. But you note that the sum of these two intervals is actually equal to the length of the basis of the edge of box. So you have that d11 of P plus d21 of P is exactly equal to omega 11 plus omega 21. Equilibrium of the market of good one. The same thing holds for the second good. This is the demand of second good by the first consumer, and this is the demand of second good by our second consumer. Analogously, if you sum these two intervals, you obtain exactly the length of the height of the edge of box. So, also for the second good, let us write, you have equilibrium quality with the total demand and the total endowment of good, total endowment of good 2. Is it clear? So, in substance, you can identify the general economic equilibrium, in other terms, a situation in which every market is in equilibrium, simply by detecting the optimal points. If they coincide, you have general equilibrium. If they, for example, do not coincide, as in this case, you have not an equilibrium. Is it clear? There is an alternative way to represent general equilibrium by means of offer curves. This is omega. Let us trace the offer curve of subject 1. Suppose that this is the offer curve of subject 1. And this is the offer curve of subject 2. Do you remember? The offer curves are simply the locus of the optimal points chosen by one or the other consumer when the price system changes. It is clear that the equilibrium is represented by every point in which our two offer curves intersect. Because clearly This means that if you trace this budget line, you have both for consumer 1 and for consumer 2 tangents between the highest in different schools and the budget line. So every intersection of these two curves, but for the initial endowment, represent a general equilibrium. Bene? Is it clear? So, is it clear? So you have two alternative ways to represent in the edge box the equilibrium, by means of usual different curves and by means of offer curves, but substantially they are equivalent. Note that the point omega, which is clearly the point of intersection of the offer curves, generally does not represent a general economic equilibrium, but for the case in which the offer curves have the same slope in the point omega. This is a totally analogous result with the usual case considered in international economics, in which these curves are the reciprocal demands of two countries. And it is not generally true that in the point of no trade there is equilibrium. Substantially, from a mathematical point of view, this result is equivalent to the analogous result in international trade theory. However, this is only for those who studied international trade theory. Is it clear? So we have two different ways to represent equilibrium. Let us have another short interval.